Hello everyone and welcome to the lecture series on Class 7 Maths. In this series we will cover the topics required for CBSE, ICSE and state boards. So let's get started with our first video on integers. So in this video we are going to address three questions. First, what are integers? Second, how to perform addition and subtraction on integers? And third, what are some interesting properties of these operations? So let's get started. So what are integers? To address that question, let's start from the beginning. The number system started with natural numbers. So the natural numbers are 1, 2, 3, 4 and so on. And earlier in the civilization, people invented natural numbers to count their herd of sheep or the cows they have or the trees. But soon they realized that something was missing and that something was nothing. How to represent nothing? So if I have nothing, how do I represent that? So that's where they invented zero. So the set of natural numbers and zero constitute whole numbers. But again, this also wasn't enough because people started barter system. They started borrowing things and giving things to others. And now you need a system to keep track of these operations. And that's where we needed negative numbers also. So that's where the whole set of negative numbers were added to the whole numbers, and the entire set is called integers. So integers have three kind of numbers. One is positive integers, which are same as our old natural numbers. We have corresponding negative integers, and we also have zero in between. So let's take a closer look. So the right side are the natural where the natural numbers are. That's the positive or increasing direction, and the left side of zero is the negative or decreasing direction. Again, one thing to note is that this is just a representation. I can draw a number line vertically, and then maybe the upward direction has a positive direction and negative direction is the downward direction. Or we could even represent it the other way around. The downward direction can be negative, can be positive direction, and upward direction can be uh, negative direction. So really it depends on how you formulate the problem. But one thing to notice that one side of zero is positive or increasing direction. That's where we perform the operation addition. When we add, we move in the positive direction, and when we subtract, we move in the negative direction. So we represent subtraction with a minus sign. We also represent negative numbers with minus sign, and what it tells is to turn around. So if I have to reach to 2, I go in the right direction by 2 units. If I have to reach minus 2, I should turn around and go in the left direction. So that's the idea of minus number. So let's see how addition of positive integers is done. So this is what we already know from natural numbers. So we want to add 2 plus 3. So we start at 2 and then we move 3 steps to the right, and then 3 units to the right, and we reach at 5. So 2 plus 3 is 5. This we all know. And but what about adding positive integer to a negative integer? So let's say we want to add we want to do minus 5 plus 4. We want to add 4 to minus 5. So the logic is simple. We start with minus 5 and we want to add 4 to it. So we move in the increasing direction by 4 units. So increasing direction in this case is the right direction. So we move 4 units in the right direction. So minus 4, minus 3, minus 2 and minus 1. We reach minus 1. So the answer minus 5 plus 4 is minus 1. And how to do this in a methodical way is what we do is we basically if the magnitude of the negative number is larger than the positive number, so 5 is larger than 4, so what we do is we flip the signs. We actually do 5 minus 4, that's answer is 1, and we attach a negative sign to it. So we'll do 5 minus 4 and minus negative sign, so we have minus 1 as the answer. So that's simple. So let's move on. So let's look at subtraction. How do we subtract a positive integer from any integer, or let's start with positive integer. So this is what we already know. So we want to do 6 minus 2. So we start from 6, and since there is a subtraction sign, so minus sign, we want to go in the opposite direction or the decreasing direction. And how much we want to go? By 2 units. So we move to 5 and then 4, and so we reach at 4. So 6 minus 2 is 4. So we start from 6 and move to left by 2 units. How about subtracting from a negative integer, right? So let's say we want to perform this operation minus 1 minus 4. So again, we start at minus 1 and we want to subtract 4. So we want to go in the negative direction by 4 units. So we'll go like minus 1, minus 2, minus 3, minus 4, and minus 5. So basically, we start from the number and we move to the left by the number we want to subtract. So how to do this methodically again? So if you have minus 1 minus, we want to do minus 1 minus 4, what we do is we just take the magnitudes 1 and 4, we add them up, we have 5, and then we attach a minus sign. So that's where we reach minus 5. What we have seen so far is how to add and subtract a positive integer. So now we want to learn how to add and subtract negative integer. So let's say we want to add a negative integer. So we want to perform the operation 6 plus minus 2. So we'll start as usual. We'll start at 6. We want to add minus 2 to it. So we want to add, so we'll move in right direction, increasing direction. But we notice that what the number we want to add has a minus sign. So minus sign tells us to turn around and go in the opposite direction. So we'll move to the left direction by 2 units. So 6 plus minus 2 would be, we'll move to the left by 2 units, 5 and 4. So 6 plus minus 2 is 4. So we notice that this is same as subtracting 2 from 6. So adding a negative integer is actually same as subtracting the positive integer of the same, of the same magnitude. Okay. So how about adding a negative integer to another negative integer? So let's say we want to do minus 1 plus minus 4. How do we do that? So we'll start from minus 1. We want to add, so we want to move in the right, in the increasing direction, but the number we want to add is negative. So we'll flip the direction and go in negative direction. So we'll start at minus 1 and go 4 units in the left. So minus 2, minus 3, minus 4, and minus 5. So we will reach minus 5. So this again is adding, again we notice that adding a negative integer to another negative integer is same as subtracting a positive integer from that negative integer. Okay. So let's move to the next topic where we want to add, we want to subtract a negative integer. So this is interesting. We want to basically do say 2 minus of minus 3. Okay. So we start at 2. Now we want to subtract, so we should go in the negative direction because minus sign tells us to turn around, and we want to subtract minus 3. So we want to turn around again. So effectively we don't turn around and we just move in the right direction. So we'll basically do 2 plus 3. So we'll do 2, 3, 4, and 5, right? So 2 minus of minus 3 is 5. How about subtracting a negative integer from another negative integer? So let's say we want to do minus 5 minus minus 4. So again we start at minus 5. We want to do subtraction, so we should move in the opposite direction, that is in the negative direction. But the number we want to subtract is again minus 4. So we'll again flip around and move in the positive direction. So we move 4 units in the positive direction and we will reach minus 1. So minus 4 minus minus 4, minus 5 minus minus 4 is minus 1. So we notice that when we subtract a positive integer or we add a negative integer, in both cases we move to the left, or we move in the decreasing direction. And also when we added a positive integer or when we subtracted a negative integer, we moved in the increasing direction, or we moved to the right direction. So what it tells, subtracting a number is same as adding its negative number. So let's say we want to subtract 2 from 6. So we want to do 6 minus 2 is same as adding minus 2 or negative 2 to 6. So 6 minus 2 is same as 6 plus negative 2. Similarly, we want to subtract minus 4. So we want to do minus 5 minus of negative 4, which is same as minus 5 plus 4. So again, subtracting a number is same as adding its negative number. So this notion of negative number wasn't there in natural numbers or whole numbers, but with integers we have these numbers. So in integers, really addition is the only key operation, because subtraction we can just represent it as adding by a negative number. So that covers addition and subtraction of integers. And by the way, what is a negative of 0? It's 0 itself. So adding 0 is same as subtracting 0, which in both cases the number remains unchanged. So with that we have covered subtraction, addition, and what is the negative of a number. So let's pause here and recollect whatever we have learned so far. By the way, to see similar videos, you can subscribe to this channel. If you have any questions or doubts, please ask them in the comments, or you can also post them on abhyasu.com. You can join live sessions at 7 p.m. every day from Monday to Friday for class 7 maths. So let's move on. So we have seen what integers are, and we have also studied how to do addition and subtraction of integers, whether they are positive integers or negative integers. We know how to do addition and subtraction. Now let's look at the third question. That is, let's look at some of the interesting properties of addition and subtraction. So the first property we want to see is additive identity. So identity is a number that when operated on another number does not change that number. So in case of addition, we want to find a number that when we add to other number does not change that number. And answer is easy. We know that adding 0 to any number does not change that number. So 0 is additive identity. Now let's look at another concept, that is additive inverse of a number. So additive inverse of a number is another number that when added to the original number produces identity, or that is it produces 0. So this is a general concept about any operator. So if you have a number, we want to find its inverse, and that inverse will basically nullify the effect of that number, and it will produce an identity. So minus 7 is additive inverse of 7, because if we add minus 7 to 7, you get 0, and 7 is additive inverse of minus 7, because basically we are adding 7 to minus 7, and the answer is 0. So a negative number of a number is its additive inverse. So interestingly, what is inverse of 0? That is, what is the negative of a negative number of 0, which is 0 itself. So 0 is additive identity, and additive inverse of 0 is also 0. So in general, this is always true. So inverse of an identity is always identity. That's because you operate identity on identity itself, and you get back identity. So that's all about additive inverses and additive identity. So let's move on to the next property, which is commutative property. We say that an operation is commutative if by changing the order of numbers does not change the result. So the question we want to ask is addition commutative? Or if we do a plus b, is it same as doing b plus a? Now let's take a a simple example. So here I'm basically adding 4 plus 3. So here is a group of 4 balls and there's another group of 3 balls, and we want to add both the groups and we'll get 7 balls. So now if I look from the left side, I see that it's 4 plus 3. But if I look from the right side, I can write this as 3 plus 4. So indeed, it's the same thing. Whether I look it from left or right, I still have 7 balls, right? So what we can say is that addition is indeed commutative. By the way, I have just mentioned this with positive integers, but you can imagine it with negative integers or combination of positive and negative integers. So you can imagine that you are walking on the number line and someone asks you to move 5 steps to right and then move 4 steps to left, and wherever you will end up. Or if we change the order and say first move left by 4 steps and then move right by 5 steps, you will end up at the same location. So it doesn't matter whether by changing the order of operations, it doesn't matter, you will always reach the same place. So addition is indeed commutative. What about subtraction? Is subtraction commutative? Or the question we want to ask is A minus B same as B minus A? So let's take an example. So we want to do 4 minus 2, and by swapping the order it will be 2 minus 4. So 4 minus 2 is same as 4 plus minus 2, and the right side is 2 minus 4, which is 2 plus minus 4, and which is same as minus 4 plus 2. Why? Because we know that addition is commutative. So now you see that left side is 4 plus minus 2 and right side is minus 4 plus 2. So left side is not equal to right side. So subtraction is not commutative. In fact, by changing the order of subtraction, we flip the sign of the answer. So 4 minus 2 is 2 and 2 minus 4 is minus 2. So in summary, subtraction is not commutative. So let's move on to the next property, which is associative property. So what is associative property? We call an operation as associative if by changing the order of operation does not change the results. So it's not swapping the numbers like commutative property, it's changing the order of associative. So the question we want to ask is addition associative? That is, let's say we want to add 3 numbers, a plus b plus c. So whether adding a plus b first and then adding c is same as adding b plus c first and then adding a. So you remember that we first operate on brackets. So a plus b plus, so the first operation is adding a plus b first and then adding c. And the second operation means that we add b plus c first and then add a. To understand the question intuitively, let's consider this scenario that let's say you have 3 friends, Arya, Basu and Chetan. And Arya gave you A chocolates, Basu gave you B chocolates and Chetan gave you C chocolates. So together you have A plus B plus C chocolates. So now does it matter if Arya and Basu gave their chocolates together and later Chetan gave his C chocolates, or whether Arya came first and gave her chocolates and later Basu and Chetan came together and gave their chocolates together? No, it doesn't matter, right? Because ultimately you will still have A plus B plus C chocolates. So in the first case, when Arya and Basu come together first, so we'll have A plus B, we'll do A plus B first, and then we'll add C to it. And in the second case, when Arya came first and then Basu and Chetan came together, we will add B plus C first and then we'll add that to A. So we know intuitively that it doesn't matter who came first or who collected the chocolates together. So indeed, addition is associative. A plus B plus C is same as A plus B plus C. So let's take an example. we want to add 4 plus minus 11 plus 5. So in first way, we will add 4 plus minus 11 first and then add 5. So we will have 4 plus minus 11, which is minus 7 plus 5, which is minus 2. And the other way, we will first do minus 11 plus 4 or plus 5. So that is minus 6. And we will add that to 4. So 4 plus minus 6 is minus 2. So addition is indeed associative. How about subtraction? Is subtraction also associative? Let's take an example. So let's say we want to do 10 minus 5 minus 5. So we will, in one way, we'll do first 10 minus 5 and then subtract 5 from that. So 10 minus 5 is 5, minus 5 will get 0. And the other way, we will do 5 minus 5 first and then subtract that from 10. So we'll do 10 minus 0 and we will have 10. So by the way, first way is the correct way. While doing subtraction, you should always go from left to right. So and the conclusion is subtraction is not associative. So let's move to the another property, and that property is called closure. It's an interesting property. So we say that a set is closed under an operation if it operates on the numbers from that set and outcome is also in that set. So what it means for addition is if we take two numbers from that set and add to those two numbers, is the addition also in that set? So let's ask the question that are integers closed under addition? Okay, and what about natural numbers and whole numbers? Are they also closed under addition? So let's just think about it. So both natural numbers and whole numbers have only positive or non-negative numbers. So if you add these two numbers from two numbers from natural numbers, so we have positive numbers, we will always move to right side. Similarly, in whole numbers also, we will always move to the right side. Addition can always take you to the right side of the number line. And there are infinite numbers on the right side. So there is really no reason why we will end up going outside integers or outside whole numbers. So both natural numbers and whole numbers are closed under addition. What about integers? So integers have both positive and negative numbers. So now by addition, you can't guarantee that you will always move in the right direction, in the increasing direction, because adding a negative, when you add a negative number, we actually move in the negative direction. But for integers, we have infinite numbers on both sides, from the both positive side as well as negative side. So there is no reason that we will run out of integers. So we move to the right side or we move to the left side, we'll have to go outside of integers. So integers are also closed under addition. So how about subtraction? Is subtraction also closed? Are integers also closed under subtraction? Yes, because subtraction is just addition of negative numbers. Adding a negative number, right? So in the same way, while we subtract, we either move to the left side if we are subtracting a positive number, or we'll move to the right side if we are subtracting a negative number. And in both cases, we have infinite numbers on both sides, and hence integers are also closed under subtraction. What about natural numbers and whole numbers? Are they also closed under addition and sorry, are they also closed under subtraction? Just think about it. And while you are thinking about closure of subtraction under natural and whole numbers, let me remind you to subscribe this channel. Again, if you have any questions, any doubts, feel free to ask in comments or on abhyasu.com. And these will be live sessions every day, Monday to Friday at 7 p.m. So please don't forget to join live. Okay. So let's summarize the closure property. We have seen that for addition, all three sets, natural numbers, whole numbers and integers, are closed under addition. That is, you take two integers and add them, you'll get an integer. You take two natural numbers and add them, you will get another natural number. For subtraction, integers are indeed closed under subtraction because subtraction is just addition of negative number. But natural numbers and whole numbers are not closed under subtraction, and that's because by subtraction we have to move to the left side, and there are no infinite numbers on the left of 1 in natural numbers or left of 0 in whole numbers, and we may have to go outside that set. So let's say I want to subtract 10 minus 100. So there is no way to represent that in natural numbers and whole numbers. So they are not closed under subtraction, while integers are closed under addition and subtraction. So let's summarize the properties of integer addition and subtraction. We have seen three properties: commutativity, associativity, and closure. And we have seen that integer addition is commutative, but integer subtraction is not commutative. Integer addition is associative, but subtraction is not associative. However, both integers are closed both under addition and subtraction. So with that, we have covered addition and subtraction of integers as well as some interesting properties. So I hope you have enjoyed this video and hope to see you again for the next video. Bye bye.